And we're here today to demonstrate the blue box system that we've been working on for a number of months here. We've got it dialed in to the point where we feel comfortable that we can produce the amount of hydroxyplasma that we need to make this car run more efficient and any other applications. So just to give you a quick introduction of what we've got going on here. Inside the trunk of this car, it's a 2007 Crown Victoria, old police cruiser that we used. Inside the box, of course, you notice all the different gizmos and gadgets here and pumps and things, and we'll explain it just briefly as we go through it. Of course, here's our water container. From the water container, the water travels from the transfer pump into the fuel cell, where it goes through an electrolysis process in a series, to break down the hydrogen and oxygen molecules. From there, it is transferred into the reactor. Now within the reactor, just as a simple explanation, the microbubbles that are being created in there through the flashback of the high voltage, which is coming back through the system, is creating the hydroxyplasma. Now plasma, of course, is the fourth state of matter, and those who understand the higher physics and science of that will know what we're talking about here. But it comes out to be an H2O2, which is stabilized hydrogen. From that system there, then this little system here is called our primary dryer. Out of the dryer, any of the other H2O molecules that are still in the system are being dispersed in here and being collected and then recycled back through for future use. And the hydroxyplasma, which is being generated from the reactor, is then going through the process and moving towards the engine compartment. Now just a little side note here about the electronics that are involved on this. On the right hand side here we have an axe controller. It's been modified with some heat sinks and some cooling fans in order to keep it cool. It has also been modified to the extent that the original MOSFETs were removed and commercial MOSFETs, 100 amp each MOSFETs, were placed inside so that this unit can run at a continuous 400 amps. All right? And the system is kept charged with a float system inside the reactor, which keeps the water flowing into the fuel cell so it never dries out. It's critical that the system never runs empty of water. All right, as we move to the front of the car here, we want to show the front of the car here in the engine. Now as that hydroxyplasma and the gas is transferred from the trunk, the blue box, down along the frame line here, it enters the system coming in at this point. Now what we've got here is we've got a secondary dryer, which we affectionately call the bubbler, which has alcohol in it. The alcohol strips off any remaining H2O molecules that may be in the system so that we get a pure form of gas going into the intake. Okay. Now with this system, we went a little step further. We put a heat exchanger on the fuel line of the original car. Now what that is doing is that vaporizes the gasoline. Now the vaporized gasoline actually combines better with the HHO. Now what the HHO does with the gasoline is it stabilizes it. So it prevents it from pre-detonation inside the cylinder of the car. We're going to demonstrate the flow rate from the blue box that is being produced with the hydroxy gas. What we're going to do is open up a small series of valves and redistribute the gas into the bottle down here into a tank to demonstrate the amount of liters per minute that we're producing with this.
So how big is your bottle?
Now the bottle is a 1 liter bottle, and this engine, this particular system, will produce enough hydroxy gas to run 4 engines this size. So anyway, we're going to go ahead and do that now, and we're going to turn the valve on. So if you'll move the camera over here, and as soon as he turns the valve on, we're going to hit the start button and then the stop button.
1, 2, 3.
Okay, we're going to do another little demonstration here. We're just going to show you some continuous flow. Here's the hose coming off of the car and on the ground, of course, and into the same container that we just did the flow test through.
30 amps.
At 30 amps. Okay, at 30 amps, you can see that there's a continuous flow of hydroxyplasma. Now we're going to show you some of the dynamics of that hydroxyplasma through what we call a little bubble test. So just give us a second here and we'll get set up for that. All right, here we are. We're going to do a little demonstration. Now, as it's been explained, the hydroxyplasma, or most run-of-the-mill hydrogen systems, will create a small blue flame once ignited. What we're doing is just using regular run-of-the-mill liquid dish soap with water. We're going to create some bubbles. The bubbles are going to encapsulate and capture the hydroxy gas, and then we're going to put a flame to it, and you'll see the difference between just your regular hydrogen system and the hydroxyplasma. So I'm going to go ahead and place this on the ground. We create a good source of bubbles. And this, my friends, is what we like to call the power of the sun. We take that amount of bubbles. Oops, let's get a little bit more. Okay, get some ignition on that. And ow.